In the previous video, we looked at the halogenation of benzene. Here, we're going to look at the acylation of benzene. So, what we're going to start off with is an acyl chloride. So we will start with CH3, C, CO, Cl. So this is ethanoyl chloride. And this is a carboxylic acid derivative, where instead of the OH group here, we have a chlorine group. Now, what we want to do is we want to substitute this acyl group onto a benzene ring. Now, as in the case with the halogenation of benzene, we're going to need to use a catalyst for the reaction. And here we're going to use AlCl3. Now, this will have the effect, again, because the Al ion here is a strongly 3 plus charge. What it will do is it will remove one of the chlorines from the acyl chloride. And this produces an electrophile here with a positive charge on that carbon. And for a brief time, AlCl4- will exist. Now remember, all these mechanisms, all these reactions are electrophilic substitution. So we're going to substitute the acyl group onto a benzene in replacement of a hydrogen. So this is a benzene ring. My acyl chloride is here. Sorry, go back. My electrophile is here. This is not an acyl chloride anymore because the chlorine's been removed. There'll be an attraction of the electrons from the pi orbital, from the pi bond in the benzene, which is formed from the sideways overlap of the p orbital electrons on the carbon, the 2p electrons. So from the pi bond, the electrons will be attracted towards the carbon, and the mechanism is very, very similar. Remember, the horseshoe does not go beyond carbon 2 and 6. The hydrogen, the bond between the hydrogen and the carbon here will be broken. So I've got my double-headed arrow showing the movement of electrons to reform the benzene ring here. And the product I am left over with is phenylethanone. Again, making sure that you are a little bit more accurate with your drawings here. But we've got phenylethanone as my product, and the hydrogen ion, the proton, will also have been released from this reaction. So I'll just move that up so you can see it. So the proton has been released here as it came off and it was removed. So the proton again is removed by the AlCl4- like in previous reactions. So we need to show how the catalyst actually reforms. AlCl4- plus the proton that is removed from the benzene ring, making us AlCl3 and hydrogen chloride. So hydrogen chloride will be produced. So an issue of this reaction is that we have toxic fumes of HCl produced. Something that you need to be aware of and you need to be careful of if you're writing an exam and it's one thing to explain as an issue with this type of reaction.